Hi everyone again. My name is Gaz, and today I'm here to present our transit headway management tool, which was designed to have something to control the reliability in the transit system in real time. Let me start with defining the core problem we are trying to address, the reliability in the transit system. In an ideal system, vehicles should arrive at regular intervals, the scheduled headways. But in practice, it often breaks down. And based on this, we define two main issues, the bunching and the gapping. Bunching happens when the real-time headway drops below 50% of the scheduled headway. And in simple terms, it means that the buses are going to be closer to each other, as you can see in the first picture. And it means that the first bus, the leader bus, most of the time will be overcrowded, and the other one, the leader one, will be underutilized. The second issue that we are experiencing is the gapping, which is the opposite of the bunching. It means that the real-time headway exceeds 150% of the scheduled headway. This means that the passengers would experience a very long waiting time and uneven services. These thresholds, the 50% and the 150%, are letting us and allowing us to detect the bunching and gapping and also quantifying the reliability in the transit system. But how does this affect? First of all, the riders. They experience uneven services. They cannot trust their travel times. They are going to experience longer waiting times and crowded buses. And also the bus drivers, the operators, it is more harder. It's harder to manage and recover in these situations. And also the supervisors in the transit control room, for example, in the TTC, they need to make real-time decisions to alleviate the situation of bunching and gapping to restore the balance over the network. So these are the three groups that they are affected. But what is happening at the moment in most of the transit agencies? What is the status quo? Most of the agencies rely on real-time AVL data, and they have a dashboard that is only descriptive. It means that it only shows you what's happening in the system. Where are the buses? And supervisors need to monitor this information manually, identify the issues, the bunching and gapping again manually, and decide when and how to intervene to alleviate the situation. So this process is reactive, it's related to the experience of the supervisor and often delayed. By the time they are making any recommendation to the drivers or doing anything, the bunching has already propagated along the route. But what we are suggesting to add a dedicated intelligence layer, and instead of just showing a descriptive analytics of the descriptive of the what's happening in the system predict what is going to happen, what is which part of the city has bunching event, and also make some actionable recommendations to the supervisors. So supervisors are no longer needed to make any monitoring continuously, and they are supported through this layer by these recommendations. For example, this recommendation can tell them which bus at which stop for how long. You can just ask them to be hold, and then how this recommendation would affect the system. I should note that this process would not replace the human or the supervisor at all. And at the end, this is the supervisor who make the decision and make the call, and they just have more information, they have more suggestion, and they can make the decision more quickly actually. So we are moving from manual reactive control to a data-driven, predictive, and decision-supported operation. Let me explain how we define which data we are using. The main data I should say that the most important and actually the only data we are using is the GTFS, the scheduled GTFS or the static GTFS, which includes the trips information, the stops information, the shape, the routes, the trajectory of the routes, and all of this information that get updated every 45 days approximately, and they are publicly available. And also, in addition to that, we are using the real-time GTFS, which is a real-time feeds that tell us where are the buses, and if they have passed the stations they have on the scheduled GTFS or not, and what is happening actually at the moment in the system. By matching these two data and having the prediction model and the optimization model, we had this supervisor tool overview. In this part, in the left side, you can see the location of the buses and the direction of them and how they are moving. The ones that are red are the ones that are red or green are the ones that are experiencing the bunching or gapping. But the difference between red and green, for example, here between these two, is that we have a recommendation for this one, and we can hold this stop for a specific amount of time at this stop that was flagged, and alleviate the situation. But this one, we cannot do the holding because of different reasons. For example, there are too many passengers on that bus, or maybe the bus behind this bus is also experiencing a bunching, so that doesn't make sense to hold this bus as well. So there are so many factors that are considered in the optimization model to decide which bus to stop, to hold, and how much to hold it. And on the right side, the supervisor have all of the information they need to apply that recommendation or ignore it. And when they apply it, they make a call and advise the driver to do the holding for that specific amount of time. For example, we are telling this vehicle ID to stop at this specific stop, and they need this block ID to find this driver easily, and also how long they are going to ask the driver to do the holding. And they can just do the apply or ignore over each of the recommendations based on their own experience and domain knowledge that they have. The tool has been used by TTC Transit Control since mid-November, and I'm going to share some of the results with you. But we have a functionality that tells us how the system is working, how they are using the tool to evaluate the impact of the tool on the system and also the supervisors. I want to share some of the most recent results with you. Let me first explain how we define the results and the KPIs that we are evaluating based on them. First one is the resolution rate. It means that, okay, we had a bunching event and the supervisor decided to hold that specific bus based on that recommendation. Okay, after 14 minutes, what happened? Was the bunching, was the situation of bunching completely resolved, or was it worsened, or what happens actually? What was the result of this holding? And also, the second item that we do the KPIs, follow the KPI factor is the holding applied rate. We wanted to know how the supervisors interact with this tool, how many holding intervention they actually applied, how many of them were declined, and what was the reasons, were the reasons that they declined. Because when they declined, they can told us, they have a drop down menu to say that, okay, based on our knowledge, this bus cannot be held, or there are some other factors that actually sometimes the supervisors decline the holding action, and based on their knowledge, for example, they do something else. For example, they suggest the driver to do a short turn or other actions for controlling and managing the transit system. So based on our recommendation, they will be aware of the situation, and then they just change the action based on their own domain experience. And what was the result for the November, December, January, and February? As you can see, we had different factors for maximum for a day or minimum day. And also the most important factor is the resolution rate. It means that in November, the first month of the pilot, actually, the 68% of the holding actions resulted in solving the bunching event. And it has been, as you can see, it has been increased over the months because the supervisors learn how to use the tool more. They trust the tool, the drivers trust the tool more, and it was increased over the time. And the holding applied rate was increased incredibly as well because as I was mentioning, the supervisors was trusting the system more, and these are the applied rates. And then ignores. I'm going to explain more why we had the ignores. We observe and evaluate what was their top reasons, and most of the top reason over each of the months was the vehicle capacity. And this was because the vehicle capacity that we have in the real-time GTFS is just a five to eight categories of the capacity. And it was different because when the supervisor called the driver and asked them to do the holding, they told them that, okay, your information about the capacity is not accurate as mine, and it's better not to do the holding. And this was the main reason, which was related to the GTFS real time. And we also evaluate how this reasons was changing over each of the months. And also, as I was mentioning, we do not want to hold any vehicles with a full capacity. And you can see that over each month, we only at most we have hold a bus at full capacity 2%, and most of them were empty ones. And this is how we are affecting the waiting time of the passengers on vehicle as well. And if I want to have a very overall overview of the performance of this tool, I can explain that the resolution rate was about 76%, and the holding applied rate was 57%. And the operators actually trust us 3 times more than when they start using that tool. And the resolution is improving month by month, and also over 3,000 applied holding has happened during these months, and about 70 to 82% of the holding actions was just for the empty vehicles, which means that it affected the system the most. And what's the next? Actually, we wanted to expand our routes because it's actually has been piloted for 6 routes. And actually, recently it has been 9 routes. We have added some more routes here as well. And we wanted to do some stop level analysis to find out the cause and impact of the holding, and also why we have the bunching event at the stop levels. And we learned from this tool and this project that the decision support must match real workflows, so we can work with the supervisors. They can use the tool actually, and it can be working. And also the small targeted intervention can create system level reliability gains, and also the possibility to improve the real-time GTFS, especially regarding the capacity information that we are getting from that. And that's from my side. I'm happy to hear if you have any question. Thank you for having me, and also the all of the sorry, wait, give me a second. And thank you for your attention. Sorry, I lost my.
Hi, thanks for the presentation. A really nice problem and solution. One thing I was wondering was, for the metrics, did you do a control metric for say resolution of bunching, for example, like for control period where you did not apply the solution, because that would be, I guess, the comparison to whether your solution is like basically without your solution and with your solution, what were the rates of bunching? That might be a metric that I would be interested in seeing. And also for modeling whether buses are being bunched for a machine learning solution, could you speak a bit more to that? Did you predict whether buses would be bunched, or did you predict buses positions over time and like calculate metrics off of that? I'm just curious to know more about like the solution you used for predicting whether for getting your recommendations to the supervisor. Yeah.
Thank you for your question. I just make some notes so I do not forget to mention all of them. For the last part that you mentioned, we are doing the prediction for how many bunching would happen at each route for the next 30 minutes. And this helps us, the supervisors, to understand how the system is going to happen in the next 30 minutes. And that helps them to make the decision if they really think that they need to do the intervention or not. And also another thing that we are doing is to predict the arrival time at each of the stops. It is not yet integrated into this version, but it is the another prediction model that we are going to have. And the other question that you had regarding the how we evaluate the effect, and is it if I understand it right, you wanted to know that if you wanted to compare the to do not nothing to no nothing to do scenario and the case that we are doing the holdings. And actually the KPI that I mentioned, the resolution rate, is showing this result. If you do not do the holding events, for the ones that you have done the holding, the situation in about 80% of the situations was alleviated and was removed and resolved when you do the holding. So it shows that it has effects on the system. And also I know that the TTC team also has their own KPIs, which I'm not sure if I can share them or not. But based on that, based on their evaluation, it was showing that how this holding was making the situation of bunching and gapping much better in the system for the routes that we are doing the pilot with.
Okay, thank you.
Guys, thank you so much. This is great. It's so nice to hear how there's a really defined workflow, and then where AI puts in to say, "Hey, here's what we want to figure out with the workflow." So that's great. So nice here. I guess my question is, I guess sort of a bit what's next from your six, I guess, route pilot. Have you had a chance or ever thought about what's next to actually talking to, or had a chance to think about how to talk to real users, like the actual operators, the actual bus drivers? Is that something in your plans, or that's something that's needed, not needed? I'm just curious.
Actually, while the pilot was running, we were in the transit control room. And in
Oh,
that area, yeah, the supervisors was in the connection with the drivers, actually over the phone or over their own messaging system. And we were observing how the system is working and how it is affecting the drivers, actually, because the drivers are the ones that are on the situation at the moment, and they can tell us that how the system is working, if that's enough for them, or if they can follow the instruction or not. And we have been there for, I think, I would say maybe 5 to 7 times or even more. For me it was 5 to 7 times, but other team members has been there more as well, to see how the system is working. Because as I was mentioning, we care and we know the system is affecting the riders, drivers, and the supervisors. And we want to make sure that this benefits everyone. For the riders, we consider that we do not hold a bus at a full capacity. For the drivers, we are in connection with them, so we know what's happening, and the supervisors are giving us feedbacks actually continuously on how the system interface or what information they need more. For example, the block ID that I was showing you on the interface of the supervisor tool was something that they have requested, because they told us that if we have this information, it's easier for us to find the driver and other information. So we are in direct connection with all of them.
Oh, it sounds like you learned a lot. Like, is that something that's useful for us to learn from? Like, talk to folks. It sounds like you learned a lot.
Yes. We learned, for example, the ignoring reasons was something that we learned from the supervisors. For example, when they wanted to, instead of doing the holding action, doing the short turns, or the issue with the not I should not call it as issue, the different capacity values between the real time and what's happening there was something that we learned during this process. Thank you.
Hi guys. I wanted to ask about the rejection. In the later months, I noticed the highest reason was capacity. Do you not have access to that info, like how much a bus is full? I noticed on the TTC website that info was there, so I was just wondering.
Yeah, we have access to the capacity information that is coming from real-time GTFS. And it is something publicly available. And I think you have seen that information on maybe some applications such as Google Map when you are riding with transit. You can see that it says that it is at full capacity, how crowded is the bus, or such information. And TTC has its own information as well. But these are some categorized level: the empty, few seats, many seats. I cannot recall all of them. And sometimes the real-time GTFS that is returning the capacity information is different from what we have actually on the buses, or sometimes the expectations or understanding of the drivers are different from what we have from the real-time GTFS. So that's why the supervisors just connect with the drivers, and based on that, they decide what to do.
Thank you.
Thank you. Thank you so much, Gaz, for joining us. If you have further questions, you can join the breakout room.